Let's revise the laws of exponents. Before we start, remember that the exponent tells us how many times we have to multiply the base with itself. In this example, the base is 4 and the exponent is 3. That means we have to multiply the base with itself 3 times. 4 times 4 times 4. In this example, the base is 2 and the exponent is 5. It means that we're going to multiply the base 2 with itself 5 times. Our first law states that when we multiply with powers and the bases are the same, we add the exponents. In this example, we have f to the power 4 and f to the power 3. Our law of exponents for multiplication says that we have to add the exponents, which means we're adding the 4 to the 3. To simplify this, we would then write f to the power 7. Remember that we can only apply this law because the bases are the same. Our second law is for division, and we can also only apply the law when the bases are the same. When we divide powers with the same base, the exponents are subtracted. In this example, we have two exponents with the same base, one to the power of 9 and the other to the power of 3. The sum is to divide, so we're going to subtract the exponents. 9 minus 3 is 6. Our answer is a to the power 6. In algebra, most division sums are written like this: m to the power 12 divided by m to the power of 5. Because it's division, we're still going to subtract the exponents. Remember that we're only doing this when the bases are the same. M to the power 12 minus 5 gives us m to the power of 7. Our third law states that when we raise powers to another power, the exponents are multiplied. In this example, we have s to the power 4 in brackets to the power of 3. This means that we're going to multiply 4 and 3, which gives us s to the power of 12. Our fourth law states that when different bases are multiplied or divided and raised to a power, each number is then raised to that power. In this first example on the screen, you will see x times y, both to the power a, which means x to the power of a, times y to the power of a. This is when our bases are different. Let's look at an example for division. In this example, we have x to the power b over or divided by y to the power of c. All of that is in brackets and raised to the power of a. This means that the power applies to both x to the power b and y to the power c. Make sure that you understand how this should be written. In this first example, we're going to multiply power of 4 to both of the exponents inside the bracket, which we do because the bases are different. On top, we have a squared, which we're going to multiply with 4. And at the bottom, we have b to the power of 3, which we're going to multiply with 4. This gives us a to the power of 8 over b to the power of 12. Because the bases are different, we can't simplify this any further. Let's look at an example with multiplication. Because d and e are different bases, we can't add the exponents together. So what we're going to do is we're going to take the 3 outside of the bracket and we're going to multiply it into both of our exponents. D to the power 4 times 3 gives us d to the power of 12. Our multiplication symbol is still there, and e to the power 5 times 3 gives us e to the power of 15. Our next law states that anything to the power of 0 equals to 1. In practice, you might see a sum like this: x to the power of 4 over or divided by x to the power of 4. According to our laws of exponents, because the bases are the same, for division, we're going to subtract the exponents. X to the power 4 minus 4 gives us x to the power of 0. As per our new law, everything to the power 0 is 1. Our next law states that when we raise any value to the power of 1, the answer or the value remains the same. So x to the power 1 is x, a to the power 1 is a, 5 to the power of 1 is 5. In practice, you might find a sum like this: x to the power of 4 over or divided by x to the power of 3, which means that because the bases are the same and it's division, we're going to subtract the exponents, giving us x to the power of 1. And because anything raised to the power of 1, we have the same value. Our answer for x to the power of 1 will be x. Our last law states that when we raise a base to a negative power, we have to flip the fraction so that the power is positive. In this example, we will then have 1 over 2 to the power, and we will have a positive exponent of 3. Make sure that you pay careful attention to how this is written. We have 1 over, and the exponent becomes a positive. We're not finished simplifying this example yet because 2 to the power 3 equals to 8. We're multiplying 2, the base, with itself 3 times as per the exponent. 2 times 2 times 2 gives us a value of 8.